actually the product manager of databases at Canonical, and today I'm going to talk to you about running MySQL on top of Kubernetes. What kind of pitfalls you might run into, and what are the best practices that we recommend for you to run your MySQL on top of Kubernetes. And actually today I am together with Lena, Alex, and Nicola. We are all part of the Canonical team behind the work that you will see here and more actually. So as you can see, those are confidential slides. So I'm able to show you the rest of the slides. You just need to think and listen in your head. So for the agenda for today, okay, no surprises. We are going to start by the pitfalls of running database on top of Kubernetes and some of the best practices that we learned, from our experience regarding running MySQL on top of Kubernetes and actually any database in reality on top of Kubernetes. And then some kind of discussion point or forward-looking statement how we can even, improve, hopefully. Further, let's say our experience of running database on top of Kubernetes. So the first thing that I'm going to talk about is placement constraint. And by placement constraint, I mean giving a set of pods, in this case MySQL pods, how to dispatch the pods over the worker nodes that you have, the Kubernetes worker node that you have. And in our example that we'll use in the upcoming slides, we choose to have 3 failure domains. So failure domains can be availability zones, can be nodes, can be racks, whatever really you consider your failure domain. And here you see some labels. So those labels like NVMe SSD or SDD basically are the type of storage that those nodes can provide to you. So the most basic, type of placement method is using plain node selector. And you can, for example, say, in the pod spec, that I would like my pods to be scheduled in the nodes that have as a label disk type NVMe. And here you see in green the one that can be actually considered for scheduling, if that's the only configuration that you have. But obviously with, 3 nodes, it's not that complicated, but ideally you would like, your, pods to be scheduled on a node in each of the failure domains that you have. There is another construct called node affinity, which is, a way to see it is a better node selector or slightly more, advanced node selector, where you can actually have required, constraint, as you can see here, and you can as well have some preferred, constraint, meaning that the scheduler will try to honor them, but if he is not able to, then it is fine. And then in order to actually reach the situation that we aim for, we can use something else that we call pod anti-affinity. And here we actually try to say that we don't want 2 of the same pods to reside, on the same, zones, yeah? This is the idea here, yeah? And zone is failure domain in this case, whatever your failure domain is again. But the question that you need to ask is actually, what happens if you lose actually this failure domain? Completely, there is a downtime here affecting your failure domain. And actually, depending on the configuration that you go for, you might end up actually rescheduling some of the pods in the other failure domain too. And even after, this failure domain is up again, you might still be in the situation that you don't want, ideally, which is to have, 2 nodes in one failure domain 2 and the first node in failure domain 1. And even slightly more complicated is how to, schedule the pods if you have 4 of them and only 3 failure domains. And you can see that probably you can make it happen using, those constructs, but it becomes really not very intuitive because you are trying actually to spread, your pods over, failure domains, but you are trying, to basically find workarounds where you can express that using other constructs. So something that was introduced, in the Kubernetes API is to use something we call topology spread constraint. And as the name implies, it helps you actually express your wishes or your requirement in regards how you would like to spread your pods. And if you can see here, you can actually use many of them. So there is one that is based on the zone, another one based on the node. And how you read that is basically you are trying to say, I would like at least to use 3 zones and at least 4 nodes for the pods that I have. You can as well, authorize some skew, meaning, you might, for example, if my skew is 1, it means that you can tolerate having one of the pods not respecting your topology spread constraint. Please interrupt me if you have any questions or comments or addition. Yeah. And this should work fine, okay, with affinity, like to reach the situation that you would like. Note that you need as well to explain how you would like to treat node affinity policy if you have one, and here we choose to honor them. But even with spread topology constraint, you have all these limitations, and I really advise everyone to go over them and to understand the implication for your environment, because, it depends really in your environment whether they make sense or no. So the first thing is that those constraints might not remain actually satisfied when pods are removed. So if you are removing actually pods, yeah. And even equally worrying, I would say, the scheduler does not have prior nodes on all of the zones, because actually he will rely on the nodes that you have at a given moment to understand what are the zones available. So if you have only 2 nodes in 2 zones, but you have 5, you will use only those 2. And there are other ones as well, yeah. And in my opinion, today, the best that you can actually do on Kubernetes is to use both topology spread constraint and taints. So taints are and tolerations, because taints are on the node level and their equivalent on the pod level are toleration. So topology spread constraint will allow you to have this spread, logic, and toleration actually will help you, make sure that some constraint regarding your, nodes are respected. So for example, let's say that you have, a node that have both NVMe and GPU, but you don't want, let's say, your MySQL database to run onto, then you can, using toleration and taint, to say, okay, I would like to expel or to prevent any MySQL pod from running there. Okay. And that's, the pod affinity, those checks, toleration and taints, are checked even at runtime. So even if there is something that happens that impacts your infrastructure, like, failure domain is down, they will still be evaluated later on. It's not the case for all the other methods. This one is very interesting for me because when, for example, your node is unreachable, let's say that you have split brain scenario and whatsoever, you can actually, using, let's say, toleration, instruct Kubernetes to not try immediately, at least, to relocate your pod, which is something that you want actually with the database. If the database is big and you don't want, to generate SST because it's costly and it generates a lot of traffic and so on. And that's the best thing that we can actually do, in my opinion, using, the built-in construct of Kubernetes. Something as, I already said it, but it's really important to highlight it once again, is that the only actually placement method or construct that is checked sometimes at runtime is the taints and toleration. Everything else will be only done the first time you schedule, but if there is something that happens that is impacting your environment, as we did see in the limitation section of spread topology constraint, it might not be reevaluated actually.
So doesn't this screen for an operator?
Sorry?
Doesn't this screen for an operator?
Yes, absolutely. But even the operator, at the end.
Well, no, but that's the specific thing that's aware of these things to.
Yeah. You are going a bit, faster than the presentation, but absolutely, definitely. Other problems that you will get exposed to if you are exposing your database outside of Kubernetes. And here we might have a discussion why you would need that if you are betting everything on Kubernetes and both your application database are running on top of, inside Kubernetes actually, because if they are running the application on the database inside of your Kubernetes, all those problems you might not be exposed to. But because most, for example, the Kubernetes upgrades happens out of place, actually, even if you don't want to, you might need actually to deploy your cluster across Kubernetes clusters. And therefore, you will end up actually being exposed to the same problem, even if you didn't expect or want to in the beginning. And what we have actually built-in methods like of Kubernetes. So we have the node port. So you can create a service of type node port, and basically it will open the same port on all the nodes, which is important, all the nodes, even the one that do not have MySQL running. Which, if you have some security colleagues, they might be worried too much about that, because, if you have a cluster of few or 100 or few dozens of worker nodes, and then you open the same port everywhere, they will not be happy, and we should understand them. And if you open the node port, it means that basically your clients who are sitting outside of Kubernetes, they need to connect all of them. So you need basically to instruct them to do so, and of course, all your nodes. And you need to use something like MySQL router to, intelligently, route the queries where they should be, depending where the primary is residing and so on. And something important is that depending on your configuration, if actually you are targeting a node that is not hosting anymore MySQL, then you will have like this routing done for you, which might be seen as a good thing or a not good thing because of the introduced latency. The other option that we have is load balancer. So the load balancer is something usually provided by your public cloud provider or cloud provider, whatever it is. And it will be provisioned by Kubernetes for you if it's supported. And it is per service. So for every, let's say, for every database you are going to create a service and expose it, then you will have one per service. And depending, on the way you are deploying, that might generate a lot of, cost for you. And as you might see as well, it means simply that there is another hop as well, yeah? A network hop, meaning, we'll have one here and then, to the MySQL nodes. And behind the scene, it's using as well node port to expose the internal service provided by those Kubernetes, worker nodes. And the other question is what to use actually as a, load balancer. If you use something like HA proxy, which is very reliable, everyone is using to it. It has no actually, intelligence or no awareness about the database, or is primary or is not primary. So you need actually to spend a lot of time doing that yourself using the liveness probes and so on, which can be a lot of work, yeah? And error prone. A better solution would be to use MySQL router as the proxy, but you are on your own. You need to do that yourself, basically, yeah? Another solution, which is the ingress control, which is, the way I see it is a better load balancer. So it is per namespace, so you can have many services actually served by the same ingress controller, but you have, different problems in the sense that today, at least in the Kubernetes world, most of the ingress control actually meant to be used for HTTP proxy, not really for TCP. So if you go to the TCP route, you need to figure out yourself, the specificity of every ingress control that you might be using. And this is basically what I was talking about, that most of them actually support that you are going to do routing at HTTP level or layer 7 if you wish. So there might be a solution through the new gateway API, in Kubernetes. And this is an example from HA proxy. And you see there is a TCP route. But if you look into the Kubernetes documentation, official one, there is no TCP route mentioning. And they are still focusing on the HTTP one for now. Okay. Upgrades. So if you are using stateful set, and which you should do for a database or any, stateful, application, then you will be using probably rolling updates, and you need to be aware that whatever you do, the upgrade will be in rolling update fashion will always be done in the reverse ordinal order, meaning that they will upgrade the, pod with ordinal 1 before ordinal 2 and so on and so forth. Which means that if your primary is not ordinal 1, you might end up actually having more role switches and more outages than you actually expected. You can actually play with partitions to try to control that, but it's not simple, as we can tell from our experience. It seems that in Kubernetes, 1.31, there is this new thing called, start ordinal, where you can kind of control the ordinal of your pods. But whether I didn't play with it yet. I just discovered while writing the slides. But whether you can do that dynamically and how the cluster will behave is still to be seen. So now that we, have covered some of the pitfalls, there are more, but for the sake of time, we will, just stop there. So the first thing really, and I don't mean it really only as a joke, you really need to run your MySQL fleet on Kubernetes. And, I'm trying to repeat it twice, 3 times, because unless you are really, that's your only option, all your company is betting Kubernetes and you don't have any other infrastructure, then yes, it might make sense. But for me, you need really to think about all the workplace.
But there is, it's more lightweight than running it on a VM or something similar. So that, from that perspective, it's desirable. I don't think there's a doubt about it.
Yeah, it is something that you are gaining, definitely. But what I'm trying to say that regarding all the drawbacks that you might have, it's actually worth questioning whether you are gaining at the end or no. And if you go that route, actually my intuition would be saying, why you don't use containers but still drive them yourself? Okay, and
well, there is a container for MySQL, blah 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 blah, which does this,
yeah, absolutely. But let's assume that you went for that route for whatever reason. The first thing is to do it, in my opinion, is to dedicate some workload nodes to your database workloads. Why is that? Because you might want actually to optimize some CCTL settings, and therefore, and some of the CCTL settings are actually the one that makes sense for databases, does not make sense for other applications, like the famous transparent huge pages and so on. And therefore, that's the minimum for me. In my opinion, you need even to consider using dedicated Kubernetes cluster for your databases, if you can, afford it, obviously. And I think you need even consider deploying your instance across Kubernetes cluster, again, because of the reason that we did discuss about Kubernetes cluster will end up being updated. And today, 99% of them will happen out of place. And what you do in that case with your databases is still a big question mark. Yeah? Today, the best thing that you can do is really doing this, using topology spread constraint and tense and toleration to implement whatever your placement strategy is. Today, there is no better method. In my opinion, if I can, because sometimes you cannot, because, if you are running your Kubernetes in a standard way in the company, they will tell you, you cannot do that. You would really ask whether you would like to just use the host network and get rid of all the complexity related to ingress and so on and so forth. Okay, consider using local store for optimal performance. It's not really specific to Kubernetes, but it's worth mentioning here. And for me, the other thing that you need to consider wisely is where you place your proxy if you ever need them. So this is basically all the options that I can think of. You might have more. So this is the node where the client is running, and this is the node where the database is running. And basically either you place your proxy on the client side or on the server side or on both, or you have something in between, the load balancer that does that transparently for you. In my opinion, if you need a proxy, then probably your best guess is option 3, okay? Where you have Unix sockets here and Unix sockets here and only one hop between both. Why you might need actually, by the way, they can be not the same proxy. For example, you can be using here, MySQL router and there something built in HKRCP, which is embedded in the code if you are in the Java world. So you are not, you don't need actually to run the same one. And by doing this, actually, you will cover all the cases, because if you have this situation, okay, and you still have actually a lot of clients in the same node, you might actually be missing, an optimization, at client node side. And if you are on the other side, meaning on option 1, where you have a proxy at client side, but not on the server side, and you have a bunch of clients like thousands, you will end up actually not really optimizing a lot. So this should cover most of the cases, in my opinion. This as well has some advantages, disadvantages, but as we see, there are additional hops, and definitely from performance-wise, if you have a busy database and busy clients, you might see it. Another, legit in my opinion, recommendation is to not try, to reinvent the wheel completely. I mean, if you are in the business of creating operator, why not? But even in that case, start probably by forking one. That's what I would say, yeah. And use one of the proven operators. So here I am showcasing ours, the one that we developed at Canonical. There are other options that are very, as well recommendable. But here, in our case, what is different is that with the same semantics, as you can see here and there, you can deploy actually MySQL not only on top of Kubernetes, but as well on top of VMs. You can even have, let's say, cross-cluster replication, between, for example, Kubernetes, one Kubernetes cluster, another Kubernetes cluster, as we did recommend. And we are even working, let's say, to make it happen across, substrate, or what we call cloud, meaning between a MySQL that is deployed on VMs and a MySQL that is deployed on Kubernetes, so that you can test, see if you like it or no, and probably fall back if you are not happy with the result. So what we would need, in my opinion, to go further than this is really, first of all, more holistic approach to placement constraint, because for me, it looks like an optimization problem or constraint problem. And in my opinion, I don't see why we don't express it such as, that problem, where basically we are having an attribute that we call placement, and then we express things like, I would like the placement of MySQL 1 and MySQL 2 to be different, like distances 0 to 0, or I would like them to be at least, far. So at least far, it can be at least one node far or one rack far or one availability zone region. Or just you would like to maximize or minimize something, and you tell basically the scheduler, please maximize this as much as you can. Okay. Simpler ingress semantics. It's really a question mark why I don't know, probably some of you know what's the reason behind that, but why we don't make the node port only exposed on the consent port as where the consent port are scheduled, and even if there is a port that is rescheduled, you can still open the node port before actually scheduling it, instead of doing it the way we do today. And I know this is not a new idea. Some people did try it. Some solution exists. They are not all open source, or they are not satisfactory, at least in my opinion. But what we need, in my opinion, to solve a lot of these problems is at least an open source and database aware deployment controllers that knows where is the master, how many replica you have, and try to minimize things that we as DBA or database professional, we care about, like primary switches or, big transfers of data. And only by doing that, I think we will make hopefully the life of us as on the database server side, and as well the developer side, hopefully much easier. That was everything on my side. I think we have time for question if you have more question.